Hey guys, welcome back to the channel. This is going to be a very interesting video, very educational too. I'm going to explain a lot on these two computers you see here. One is for a 2006 C230 Mercedes-Benz, and the other one is for a 2007 GL450. The C230 is a B6. It was sent to me by Pedro from Puerto Rico, check engine service, Puerto Rico. Pedro Rivera Negron, a very good friend of a lot of people. He's a great guy. He's a great technician. He diagnosed this computer as bad, and then he sent it to me to see if it's repairable. Upon arrival, I open it up, and yeah, it's definitely not. I'm going to show you in a second why it's not repairable. As you see in the screen, I have a lot of information ready to go. I always try to gather the information as quick as possible, so I'm not looking and looking and looking for information and making the video too long for you guys, even though always get very long, but it's because I try to share all the information possible. So please stay tuned. If you want to learn how to diagnose European vehicles, and this will apply to any European vehicle and actually to any vehicle, you need to get yourself a multimeter. You need to check powers and grounds, communication lines, and etc. onto a module before you can call bad. Obviously, if you have no communication and you go and powers and grounds are there, or a fuse is blowing, well, then that is a hint that is most likely telling you that something is wrong. But yeah, so he did quite extensive um, diagnostics. As you can see, he print all the upon arrival. Um, then I recommended to disconnect the PCM or DME and then reread the faults, and he did. So let me just get these papers out of here so we don't need this no more. Um, the reason I have another computer already open, this is a computer that was left in here, again, a no repair on a Mercedes, and is almost the same look. One is for 6 cylinders, the other one is for 8 cylinders, but the actual footprint of the computer internally is really close. And that's why I'm going to use it as an example on a test because Pedro's is really, really damaged and it's super shorted. All right, so, but let me start the screen recording. Okay. All right, guys, as you can see, I'm using in here Identifix. This is again, 2006 Mercedes C230 Sport 2.5 V6. All that information is coming from the bin. All right, so nice about um, Identifix is it gives you locations of components and splices with pictures. All are Mercedes-Benz information. Looks like a Mercedes is stepping up in the game. Again, I have the computer in here, so let me set up the tripod. It's going to be a little weird just for a second, so bear with me while I am putting you guys in here. Because this is, I think, is going to look really good. So you guys can definitely see what I'm doing. I'm trying to get light close to where we're going to be doing tests. And get the computer open. This is going to be a lot easier to open because I already opened that computer. That is a socket that just fell in there. And we can keep that here. All right, you guys are really, really good location. Everything is working good. Let me just first open the computer so you guys see what I found when I opened this. This is, let me see what uh, tip is this. It's a T15. You see that this is pretty easy to open up because I already opened it. The way that I open these computers, for those that would like to ask, is I apply heat to the case with a heat gun. Yeah, you guys are in a very good chance. I mean, I'm in a very good area. And then I apply heat around, heat around, heat around until it's very hot, but not like, scoring hot. I got a thermometer, so I usually put them around 280 to 300 degrees. Then this computer has some tabs here on the back part. Let's call the front where the connector is. I open a little bit and I cut with a blade as much use of the silicone, and then I start working myself with a screwdriver or a pry bar to this way until I can get either one side up and then the other side up, but the heat will let the silicone stay, and as you can see, no damage on the cover, or at least not too much damage. I mean, you're going to seal with silicone. Well, yeah, as you can see, that is the difference. I mean, not the difference. That is Pedro's, and this is the older computer. Uh, yep, you have perfect view of that. So what I told Pedro is going to be really hard for me to do any tests when you have, as you can see, this is completely a hole through the board, and it brought it up. This is the main capacitors, main powers and grounds. This is actually attached here. This will supply power to the coils and injectors. It's the same actual circuit that is in the computer, and you will see that in a second. So the reason I had that one in here is because I want to show you that if you see these two computers and you tell me what is the difference, I don't see any. Let's say, well, let's say minimal. Let's not say any because obviously B8, B6. We have this in the B8, not in the B6, right? But for the rest, pretty much the peripherals, they look the same. As you can see, this one is missing, not because it doesn't need it, it's damaged. This is the barometric pressure sensor on this computer, but we have pretty much the same layout. 470 coil, same capacitor in the voltage regulator area. This is the voltage regulator area. And these are power ICs. These are smart drivers. And this is a very common TLE 7209. Again, this is in control of fuel pump and other things, but we're not in here, or injectors or coils, but we're not that. That's not the reason we have this computer in here. And the only reason I got Pedro right now here is to so you guys can see we got the same connectors on the computers, same connectors. Obviously in the B8 we're going to use 8 injectors and 8 coils, and in the B6 we're going to use 6 coils and 6 injectors, but the pins are there for the computer to be used either way, right? So again, if we see this way, you guys can see that the footprint on the connectors, hopefully you guys are seeing that. Yes, you are exactly the same. So these are perfect match as far as that connector. Yeah, I don't see any difference. So I want to get Pedro away from my desk uh, because it smells burn really, really bad. All right, so now into this computer. All right, let me get this out of here. So we're going to work there. Perfect. So now what I'm going to do is show you what this capacitor, the one I just blew there, is doing. So for this, I'm going to use just a multimeter in capacitor. Let me just put it down like this, you guys can see. Perfect. All right, so for those, you just go here and then you press, if you're using a fluke, you have to press that and you will see kind of like a sound line. If you click, now we have continuity. All right, so on this area, it's going to be a little hard to see because the way the Mercedes-Benz did is put a cage for the same thing in case of short or something to protect that capacitor from exploding and also to dissipate temperature. So what we're going to do is flip the board around. We're going to see that these two outside pins are just a cage, and yes, we have communication within those two, because obviously if I flip this around, well, it is the same thing, right? So this is just a one piece aluminum cage. Um, so we have the two pins on the capacitor. As you can see, that no continuity, But then if I check here, this is the ground pad. This is the bigger pad is always going to be a ground pad. So we can check with another capacitor. You see ground. The hydrolytic capacitors, again, this is a hydrolytic capacitor, usually have the mark, the black mark is ground. So this is your ground side. So if I go as like will be centered on the inside of the board, so this is ground. On the other hand, the tantalum capacitors, these are tantalum capacitors, the mark, like this line, is actually the positive side. So ground and ground. We can see that, oh yeah, so this is ground. So I can then now go into the connectors, right, and see which ones are ground. Ground, ground, ground. If I go over to the diagrams, which I have here, we can go, and this is what I have to, well, I want to have all this information ready. I have the color wire diagram right at the bottom. So let me scroll that and have the original one. I want to show you both diagrams. So we this is how I do it, because this diagram, the electrical, has an error, and it's not an error because they did it on purpose. It's actually shown on the same thing on the original, but if you look further, you would know that that is an error, and it should have been corrected by whoever designed or made all these wire redrawn diagrams. They're good. I mean, it's a lot of good information in here, but when you are missing information, then you don't know what you're checking, right? But so we can see that we have three grounds in here. So pin 2, 4, and 6. So 100%, if we go back here, again, ground of the capacitor, 2, 4, and 6. And then we have powers on there on pins 3 and 5. So this is the power side of that capacitor. This is showing on these three pins. So one might not be used for anything else than maybe just transfer, because if we touch in here, these all are share. You see? Same as the grounds. But we have no continuity between the ground and the power, right? It has to no continuity because otherwise it's shorted, right? In Pedro's, this is 100% shorted. And that's why, I was telling Pedro, it's very hard when you have a computer that is burned at that point, to that point, to do any tests on it because everything is shorted. Yeah, if a computer is damaged, not with a hole like that, I will start, doing a test and find the short. A way to do that is either apply a power. I usually solder. I find a point like this and I solder the ground and the power. And with the bench test power supply, I apply maybe 2 to 3 volts with a high amperage, maybe 2 amps. And while I'm observing with a thermal camera, what in the board gets warmer really quick, and I'm really quick disconnecting the power. You use low voltage with a high amperage, so you're not burning, because the higher the voltage, the more chance you have to go through capacitors and then to finally get to the microprocessor. And if you put like that low voltage and you apply the power, again 2 amps, and you can raise the amperage depends of the short, you will, with the thermal camera, will immediately find the spots. Sometimes it's a dead microprocessor, and the short is under there, no repair. But sometimes it's a capacitor, sometimes it's a diode, and that's a way that you can find it. The other way that you can find a short in a computer is with a 5 digit or 6 digit multimeter. I have a 5.5 digit multimeter. They're expensive. You will use a ground, and then you start checking for resistance in between ground and every component that you suspect. That resistance will increase the closer you get to the short. So let's say if I would have to, let's say, check this in resistance right now, in resistance, right? And I am in a ground. If I touch in here, we can see that that is going to reach zero point 0.2. And the problem with these multimeters is just a one digit. I can go a little better with a, with a fancier multimeter, but that's all I'm going to read. So if I check in another one, it's going to give me the zero point 0.2 again. But if I have a 5 or 6 digit multimeter, this is not going to be a zero point 0.2. When I check that, this is going to be zero point 0.2 or 0.1997, and then the other one is going to be 0.19999, and then the closest you get to the short is going to be 2, or actually it's going to decrease because more resistance, less short, lower resistance. Uh, m- uh, Let me just see. Higher resistance, less short, lower resistance, dead short, right? So if I here, this should be reading 0. As you can see, that's a problem when you have multimeter leads. You can, reset this. I have not done it in this one, but yeah, you can reset the to remove the leads from the equation. But yeah, with a 6 digit multimeter, this will become, let's say, 2 ohms, 2 ohms, 1.8, 1.6, 1.5, 1, 0.7, 0.5, and then you got 0.5, and then all of a sudden 1. Oh, you are going away from the short. So you go 0.5, 0.4, 0.3, and then 1, oh, 0.3, 1, 0.3, 0.5. This is the lowest reading. That's most likely your short. So that's another way that you can find shorts. But again, so what I wanted to do with Pedro's computer and share the information in here is that yes, this capacitor is main powers and main grounds for the ECM. So what could have make that capacitor blow the match? It's got to be 100% a dead short. If you short, let's say a coil gets shorted or an injector is shorted, it will take the computer. Why am I saying that? Okay, looking at this first, okay, let's go now to the diagrams in here. I don't think we need to be observing that computer no more. I'm going to get into the view. So I'm just going to move this my way so you guys can see me talking. I think that should be perfect. All right, so now let's do the data analysis and start doing a diagnostic. So, because yes, you have a computer short, but which one is power, which one is our ground? Why is this computer short? What could have take this computer down? This is the question that Pedro and I, or any technician will have. Okay, well, yeah, I can get a brand new computer, but if I connect a brand new computer without fixing the problem in the car, I'm going to burn the computer. And you can put 1,000 computers. You're going to be, to burn 1,000 computers. When you burn a computer, you pay for the computer. So as a technician, you are going to be the one responsible. If you're doing your own work in your own car and you plug a computer when the problem in the car has not been corrected and you burn it, it's your problem. It's not like, I mean, you can go to Mercedes Benz. It's just like, I put the computer, but it's not working, so I need another one. And they say, sure, yeah, it's $3,500. You want one, two, three, four, five, or six, I mean, that's up to you. They're not going to be like, well, the computer is bad, so we are going to give you another one to keep trying. Oh, no, 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 no. They're going to have, yeah, they're going to say, okay, what is wrong with the computer? Oh, yeah, I connected in the car. The car is not starting. They start smelling the computer, smell burn. Oh, yeah, you burned the computer. This is no warranty. Yeah, we can have problems with like software, but this is a tested, good computer. You have it now, it's completely burned. Yeah, you have to buy it. All right, so going into the diagrams. So all these again is for his vehicle. So we can deselect the grounds because now we don't really need them. But we can see powers in 3 and 5 come from here. This is the engine circuit 87 relay. It has a 15 amp fuse, but if we see right here inside, that also gives power to these two legs. So whatever can short in here, it's like almost like the computer giving power to that, right? So what is also in that leg? If I follow those in here, and I already got selected some, as you will see. So we got spark plug coils. So we got coils And I'm going to deselect this one because I just selected this one because I was trying to see where that power is coming from. Actually, no, I can select that this is coming from here, so that is here, here, and here. So no, those are from those two powers. So we have coils uh, 2, 3, 4, 5, and 6, and then capacitors. This is just a radio interference capacitors. Okay, if we follow those dotted lines, so this one and these ones are dotted lines, so we have to follow them. So we are now left intake camshaft sensor, exhaust, and intake left side, and it's also supplying powers to sorry to injectors 4, 5, and 6. All right, that's kind of weird that it's just supplying power to three injectors. Okay, what is supplying power to the other three injectors? Okay, so if we see where this power that we have already selected here is going into pin one of each of the injectors. So most of the time on Mercedes, they will be putting power on components and actuators on pin one, not the case in here, because if we see is in this left hand shaft, it looks like it's pin 3, right? But in the injectors, it follows the same thing. So if we then select the other ones, they're power here. We got a dotted line. Well, let's do the other injector here. It goes over to the master flow sensor, so we can disregard that one. So let's follow this dotted line. But this dotted line goes to the right camshaft exhaust solenoid, the right exhaust camshaft hall sensor, and right camshaft intake solenoid. So what is the power coming from? Because I didn't see it. And this is the error. So it looks like these two injectors and those other sensors are not, are powered by a magic. Because I mean there is no connection in between those and the actual power. Remember, this is all I'm trying to see is if we have a short in between these two, or you know that can create this to blow. We got a high amperage consumption. Will this blow this fuse, or will it will blow the computer? Again, there is a lot more to check, and I told this to Pedro. There is a lot to be checked. All actuators will need to be checked. The reason I'm going into injectors and coils, okay, well, yes, we have the power coming from a fuse. So if it's too high amperage of a fuse, the fuse should blow. Well, who controls the injectors in the coil? 100% the computer. Yeah, you might be having power from, in this case, if we see this right here, this is more like most likely the front SAM. So yes, the front SAM is the N10, and we'll see that in a second on the original diagrams, and that's the reason I use the original diagrams. But yes, we understand and we know 100% that coil activation, injector activation, the computer is in 100% control of that, and it's controlling them ground side. Ground side is internally on this. So yes, now you have power coming from the same side, and then the computer grounding either the injectors or the coils, actuators, right? That ground is going to try to keep those on as much as it can until, the problem is when persons has a misfire, and it doesn't get diagnosed, and then it keeps trying and it keeps trying. The computer will shut off the driver, but every time the car starts, it will keep it on for 5 seconds. 5 seconds on a high amperage draw, it can burn the computer, especially if you keep going and you keep going and you keep going. No doubt about it. And this is what we have here. I got another video coming on a 2002 or 3 Ford F-150 Lightning from Albert Moniz in in Hawaii with the same situation. We fixed that computer for him. It was working good, and the fix we did, it was a no start condition due to the analog to digital driver, or analog to digital converter information corrupted by a tune that they weren't having on the car. They got the computer back. The tune got removed. The car ran for 5, 6 days and then burned. and it burned to the point that, he unplugged one of the coils, and now the car can run with other five coils, or seven coils, because I think it's a V8. Yeah, what does that tell me? He's like, well, something is shorted on the computer, because if I put another coil, it burns the coil. I'm like, yeah, that's not the coil burned the computer, not the other way around. The computer is in control. Yes, if you have first a bad coil shorted, and you keep trying and trying and trying without, I mean, the computer again is going to keep trying and trying and trying to start a car. It will burn the computer, and that's exactly what happens. So, again, this is a data analysis that we are going to do for a computer that you want to condemn. You're going to check powers and grounds, communication lines, and fiber reference. But when you have a burn smell like that, I mean, unplug the computer. Now you know 100% in Pedro's case that that is a burn computer. We are trying to narrow down what could have taken that computer to the point that now is bad. I mean, realistically, Pedro is going to have to check every single actuator that is connected to this computer. I will check the coils, make sure they're not shorted. I will check the injectors, because those are the most common failure points that can damage the computer. Again, because of the situation of trying every single time. These have also camshaft solenoids, so those are also very consuming, power consuming actuators. So yes, we need to check those up. All right, so if we go up, and this is the way Mercedes-Benz uh, shares the information. You will have to know what the designation for your vehicle is. I have downloaded that and I have it here. So if we look for his vehicle, we will most likely have to look for information on M272. The M272, let me just make sure I'm saying that correct. C7. Yeah, M272, because we're going to have M113, N112, and then M72 for his vehicle. The only way that you really know about this is with the data card of the vehicle. I have original access to Sentry Original. With Sentry Original on the bean, you can check the data card. That is like the RO codes on a GM vehicle. They are attached to the glove box. On Volkswagens and Audi, you will have those in the sometimes in the trunk and sometimes in the glove box. Mercedes doesn't give it to you. You have to like look on Sentry with the big number, and that's the only way that unless the customer requests information from the dealer, they have to give it to him. All right, so going back to here, so this is based on his beam. So if we let me move this up a little, yeah. These are most of the components that are on the car. So we are going to see that the computer, this is very common on all Mercedes-Benz, is N310. That's the DME engine computer. The fuse box from SAM is N10 slash 1. You can have an N10 slash 2 if you have a rear SAM. Again, N15, 15. What is that? Well, the shifter, right? ABS N47, Y38. This is the conductor plate on the transmission. N73, as you can see, is the key. M1 is the starter. M33. Let me think. This is the air pump, and so on, right? So, but how I know that? Well, right here, it's not just only that. We have all the information on the left. Mercedes-Benz original diagrams are coordinate diagrams. So let's say if I'm looking for the DME, N310 is telling me that it's in coordinate 15E. If I go back there, so again, we got 14. It's a little blurry here, but we got 14, 15, and then E. So E is right here. So if you match those coordinates in here, again, like a crossing point, it's more like in the 16, but they say 15E, right? Let me just go back to the M310. Did I pass it right here? Yeah, 15E. I think that realistically, looking at this, but I think they name it where they put the name, not the actual component. So 15E, you know that the only thing in there is that, and that's how you find out what everything is. So Y38, I mean, we can just look for the Y. So Y38, Y38 electric control unit BGS. That is, like I said, that's the transmission. And yes, you can find what each of those components means. All the coils will be T's, all the injectors will be let me just see, Y62s, and it's all Y62s, Y1, 2, 3, 4, 5, 6, 6 cylinders, right? All right, so this is just for you guys to understand a little bit what is in this vehicle and get a little bit more familiar with what the wire diagrams are. Again, with this diagram in here, because if I go over to right here, splices and diagrams, let's say I'm looking for the DME. Okay, I'm going over to N310, right? So let's go over to the N310. I know I'm going a little fast, so but this is I passed it already. N310. All right, so again, let me make this a little bigger. Look for as this, you see my mouse moving on the right side middle of the screen. When I move it into the PDF for some reason it gets very I cannot change the pointer or anything. So now like I'm moving on this section and I'm going to move to the left section, left side. So again, look for that pointer right there. All the N310s are for different models of Mercedes. So again, we said that we're going to be looking for M72. So I can then copy this number on the right side, so bottom end. All right, guys, sorry about that, but yep, sometimes I got alarm set for taking pills and stuff like that, so not abnormal. Let me just put this right here again, and hopefully I can sync this again better. Uh, All right, going back to what I was saying. So the reason or the way that I could find the information N310 and then M272, it tells me to look for document number P07.61 slash or how is that? Yeah, no, that's not a slash. Underscore score U score 2101 FL. And I did. So yes, on Identifix. We got the FM and the FL. So you see, looking on, if I open the FL again for the N10 as N310, as I said, I got a partial of the engine computer's diagram. Not what I'm looking for because yes, I can see the N10 one, again, the front SEM, and some other valves and some other things in here, but I'm not really interested in anything that is in here. I'm looking for injectors and coils and yes, for Pedro, he's probably going to look into more of that. Again, this is just trying to show you guys how you find the information that is missing on that diagram. Where is that power for those injectors coming from? All right, so I can see here, you see that hand in here? Let me zoom a little more so you guys can see it better. But yes, you see this, like, I don't know, like a weird line going down, that means it's a partial. That's the way Mercedes does it. So when we are here, you see that hence it says to go over to document PE 0761 U21001FM, and that's exactly the one I have open on the bottom. So we can close this one because I'm interested in here. So if we see again N310 engine computer, and now we have T1, T5, T1, 4, 5, 6, 1, 2, 3. Again, these are the coils. And then on here, we got Y62s, 1, 2, 3, 4, 5, and 6. So they're all the injectors are here. All right, so I'm looking for the powers. I know that all the grounds are coming from the computer. So another way, I mean, and I have to really give this to Identifix. This is a great information. Color diagrams better than any other, I don't know, diagram seller in there. Forget about ProDemand. And I have it in here. I can actually open it in a second. ProDemand has its own good things, but how many information size do you need to have to work in a vehicle? You know what I mean? So let me copy the VIN number of Pedro so we can open, and then I can show you what is in here because we're going to close this information. Let me change the vehicle. I got to close all this. So most likely I'm going to have to reestablish because I think, yep, this was from yesterday. All right, so log in. All right, it's by Bean. I want to show you what you can get or not from one manufacturer or software or information site to the order. So if I go over to, let me see, C8, I'm gonna, no, C7. This is the same search that I did on no results returned from your search. It shows search in here, component location diagrams. It says C7, yeah, C7, yeah, that is, well, C7 for the N1112. How about the 272? Oh, that's not even for my car. But even here, left rear of the engine, left side. Okay, well, this is, let's say, not so bad, but that's it. I mean, yeah, left side, left rear, left rear of the engine right here. The ones that I'm looking for, C7 3C2 and C7. No, no, actually C7 35C1, left rear of the engine. Wow, wow, like it's like the engine is this big, right? No, so yeah, you will be days looking for this on there. Let me just show you what Identifix can do. I have all the already saved in here as my bookmarks, but let's say, I'm doing the search again. So if I do the search in Identifix, C7, component locations, well, I'm looking for C735C1. If I click in here, boom, look at what a difference information. Left rear of engine, yes. Yes, it's in the left rear of the engine. Where? Um, Now we know exactly. It's not just with the with the wiring exposed. It's with an error. Okay, well, it is right here under this. This is the wire loom on top of the engine, and this is exactly connector that we're looking for. Can you? This is great information. It's showing you exactly which one is, how it looks, where it's located. Even a picture of the car. This is fantastic information, and this is why I save it. So again, if I go over to my bookmarks, I should have, well, it's okay because I have all those open. So give me just 1 second. This is the same PDF file that I have open in my on my computer. It's just an image, so we got the F splice that's in here, and we're going to be using just the FL. Let me, not the FL, the FM. As you can see, I'm trying to, and I know it's going to be a long video, but if you like and you want to learn how to use electrical diagrams from Mercedes-Benz and European manufacturers, stay here because this is a good information. Yes, it's not going to be a short video. You think you're going to train and it's going to be 5 minutes? Yeah, don't. There is no fast bullet point in here or repair or something like that. No, this is where we are finding our information. All right, so if we go over to the diagram, on the original diagram, again, we're going to look for the injectors. We see that we have connector C735C. That is, again, this is a splice. It's providing power to to injector 4, to injector 5, and then to injector 6. This same splice goes here onto 1 to coil 3, and then onto coil 2. If we follow that splice, C735C1, let me see if I find it. I didn't. I can find it more in here. And here it's C735C1, but I don't know where the power is coming from, right? So If we go over to the other side, let's say the coils. I'm sorry if I'm going back and forth a little too fast, but at least in this time, okay, again, C7 is power, so we got C6 are grounds or control, right? Let me see, because W's are grounds. I'll have to see what exactly is the C6, which I have it up in the tab to pull. C6 right here. It says engine right ground connector sleeve. So that's a connector sleeve, a ground, and then engine right circuit 87 connector sleeve. So this is the C7 is terminal 87, that is power. The C6 is telling me in here the C6 is a ground connector sleeve. So yeah, that's for me is a ground, and the color of the cables is telling me is a ground. All right, so let's go up or down, sorry, again to where we were right here. So I can see that C735C2 is connected here. Let me just keep going because I'm looking for powers. Where is the power coming from? Okay, we got the N10 in here. Okay, this is C735C2, so that connects in here. We got another splice C738C2, which this one connects to. And then if we follow down, that goes through a connector and then to N10. The N10 is the front sum, so those fuses, this is power. We got another power source that comes on to this other connector and then on pin 4 to pin 2 on the N10, so this is power. So this is definitely 100% power. All right, so but we know that where the power is coming from, so C735C2, well, we already knew that. Again, let me take you down to the wire diagrams in color. I'm gonna have to reselect everything again. That's that sometimes closing the page that I have the bookmarks on is not my best help. In Identifix, you can select all the diagrams. When you click on the right where it says diagram set and remove that from the equation, now you can zoom in. So we're going to do the same thing with the powers. We already know these are, so we're going to just look for these two here, at least for now, right? And then we already knew this as supply and power right here to this. Ba, ba, ba. And then we have this one's in here. This one's in here, here, here. And we got another splice going down in here. So there's two, that's it, right? Oh no, we are going to this splice in here. So we got this one and this one. And this one's, right? So that's it. So we have injectors, uh, again, 4, 5, and 6. And coils, we got 1, 2, 3, 4, and 6. No, actually, all the coils, right? 1, 2, 3, 4, 5, 6. Yes, if 1, 2, 3, 4, 5, 6, all the coils are powered, which is weird. I don't know how they got that information because, yeah, these are my two powers coming. So let me just double check, make sure I did this correct. So we got one power here to this two. This is the other power, and it comes in here. So we got two coils that will fit to this one, and then this one here and here. So yeah. So I don't know how they got that like connected, but not the injectors, because then we have again one SR to find out. So we're missing power to injectors 1, 2, and 3. But if we go back up to the diagrams in here, are showing me that the diagram in Identifix is telling me that all coils share the same power, at least from those two wires, because they don't tell you anything about the splices or anything. And yes, this is homework. You want to make sure that you are doing the correct test, because otherwise you might be condemning a computer and it's a problem on the front SAM or something. So yes, you have to take the time on this. Um, but yeah, so this splice in here, the C735C1, is not going anywhere connected to it because I look for C735C1. I mean, I can see it right here again, C735C1. Again, two valves in there. If we want to know what Y49, 4, and 6 are, we can go over to the legend, and then we can go over to Y49's, what was it? 5 and 6. So it's intake solenoid, right? Intake, no, it has to be, well, it can be. Let me just, I'm sorry, but sometimes my brain doesn't pick up the numbers that quick. So 4 and 6. 4 and 6. So 4 and 6. So the left camshaft solenoids intake and exhaust. So yes. Um, hmm. But that doesn't go anywhere else. See, we got another C735 C2, but no, we know now that all those share the same location for power. And I don't see any connection in between C735 C1 to anything else, right? So I found another diagram. This other diagram in here, this is C splices. So again, if I go over to these component location, search A to, as I said, search A through all electrical components, so component locator. So let's go over to C's. So the C, we're going to go over to C. It tells me that C735C1 is a circuit 87. Again, we know there is a power, and look for P0 PE0019U26FA, and I have that one right here. So that's how I found this order diagram, right? So again, that punch that number because you cannot copy this information in here. That's the only thing. It's a picture. It's not a full PDF. But then I look for that, and I found it. So let's now see what it's telling me about that we could not see on the other side. Yes, look at right here. C735C1 and C735C2, they got a connector in between each other. Why the wire diagrams? That doesn't tell me that. Why the diagram that we have open in here? I mean, this is what you're going to encounter on many different diagrams because at least in here we can see the C735C2. It gets connected to C738C2, and that takes it to the N10. But if we look into the C735C1, we don't see any wire connected it in between these two. So yeah, those components are being powered up by the act of God. But yeah, you have to do your homework. So yeah, that's why, I went over to this component location, looked for that C735C1 and found that other document with original diagrams. And this is the only thing that Identifix used to give you, that is that now we have no hyperlinks. At least in here we have a one diagram. If you go and try to do this to all data, the diagram will be cut in pieces. Uh, Protoman, Snap-on, doesn't have any original information. You can request and they send it to you. I mean, I cannot be calling a Snap-on every time I need a wire diagram. So for me, Identifix is the best platform whatsoever so far compared to any other one. Yes, there are some things you can use when you have one and the other. I am working in computers. I need to have access to all of them, and that means a lot of money a year. And I think they make it on purpose. But going back to what I was saying, remember when I was showing you these numbers in here, PE, blah, 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 all this, I cannot click on that. That's just black. If I will be using Sentry Original, that will have a hyperlink. I don't have to look for that. I don't have to look for that folder with like the number and type in anything. This will have a hyperlink. I click in there and opens the document for me. And it's like when, I don't know if you guys have seen my ISTA document from I did, I think, a couple of weeks ago how to use ISTA and it's very important to use the OEM manufacturer information. Same thing in here. At least I got access to the original information, but no hyperlink. So it makes it very hard, very time consuming to take, to find all the information. If this will be again Sentry, all those hyperlinks will be there. You can see fuses, all these documents. When I populate this document, it opens a document with hyperlinks in there and tells you where fuses are located, where relays are located. It's a very, very different um, way of work with a Mercedes. If you work in a lot of Mercedes cars, you need to have that. Yes, there is. You can find Chinese computers with Mercedes software installed to it to, I don't know, maybe 2020 or something like that. Same thing as with ISTA. You don't have to buy it from uh, BMW. I will myself. I do it. I'd rather have the original information so I can do programming and coding, and it's just an expense that I can write off from my business at the end of the year. ISTA um, connector or ICOM is not expensive. It's like $750 or so. So combined with the 2,300 a year or 20, it's 23 or 2,700. I don't remember correctly. But let's say you're on like $3,500 the first time. Then the next year is just a 23 or $2,700 a year, and you have access to the latest and greatest information and everything on that. Mercedes is more expensive. Mercedes, you can buy the access to programming and diagrams and everything. I think it's like $10,000 a year. Correct me if I'm wrong if you guys are using, because the last time I bought Mercedes, I move away. I don't do much Mercedes computers to invest on that, because you can buy Sentry that will send you a computer and everything, and that costs $35,000. And I used to have that. And you can go and visit my old videos when I was working in a multi-brand shop, and then when we were working in a lot of Mercedes. I did the investment. It was a mistake, too much money. It was a loss for my end. But yeah, so I don't do that. I don't recommend it unless you are just an European shop and your majority of vehicles are Mercedes-Benz, and yes, you need to have it. It's just the best way. You got access to part numbers, to wire diagrams, to repair information, in diagnostics and SCN coding, and so on. In this case, let's go back to what we are doing in here. So I just trying to explain how different will be in order if you have the original software. But yes, that's how I found this splice in here, and we can see that C735C1 and C735C2 are interconnected. It doesn't tell me where, but now that I have even the locations of the splices, because I had C735C2 open and I know which one is that one, I can see that purple wire here. You see guys right here? Again, look for my pointer is going to become a black zoom with a plus. But yeah, so this is C735C2. Let's look at that purple wire. If we go up to C735C1, look at these wires. They're all purple. So this is just a guess on my end, but I mean, not a guess because we saw that in the diagram, but with this we know they're interconnected. So yes, as you can see, a lot of the loom on Mercedes-Benz is exposed. It's not surrounded by any. There's a tape on the engine because it's on a plastic conduit. And when it leaves the conduit, they will put a sleeve, like I have some of that sleeve in here because I do my own harnesses. Hopefully you guys can see, but yeah, this is what I use in here. So it's a sleeve, and they will tape the ends, and they tape the end with the sleeve so it's protected. And when it leaves IRS, that it's not like that. They put, heat shrink tubing and then Tesa tape on the majority. But if it's in a conduit, it will be exposed like that, which I truly don't mind at all. I don't mind having a conduit that I can remove, because this is a conduit that you just remove the clips. It has sometimes like plastic wire ties. I mean, it's very easy to get that removed. And now you get access to those splices, see if they're corroded, do all your checks in there. But yeah, for Pedro, he's going to have to check the coils, injectors, and most of the actuators until he find the one that took the computer down, because this is definitely 100%. Something else is bad in there. I will, based on experience, guess it's one of the coils. The most common failure are coils. Injectors second, and then from then the solenoids on the cams right here on the front. That's the number three. So I will start again. Coil number one, injectors number two, solenoid for the intakes as number three, source or short. All that in the engine. If you don't find it in there, then good luck and keep looking for what the list of actuators connected to that computer is, and you will find your problem. How do I check a coil resistance? You're gonna have to check a resistance. You can remove and see if it's bloated or like inflated. Most likely it's gonna have a weird smell. um, this should have had multiple misfire fault codes. It's sometimes hard when somebody brings a car when it's already too late. Somebody erased the faults and you don't have the entire history. But if you have a car that you got dead misfires on one cylinder or cylinders, then it's starting there. It can be the coil, it can be the injector. Um, Injectors are pretty easy. It's just a two wires. So yeah, you can just compare all the injectors in between each other. Remember that when they warm up, they can get short warm. So either you apply heat with a heat gun, same thing with the coils, heat it up with a heat gun and see if it goes to completely dead short. That's what you're looking for. Um, what else? The same thing with the solenoids. I apply power. I mean, yes, not power. I check the resistance and I apply heat. Remember, this is attached to the engine. The engine is going to get red. It's going to probably normal temperature on the engine 210, 220 Fahrenheit. I will go even a little higher than that, maybe because remember, you are unless you remove the component from the engine, you're going to have to fight with that big heat dissipating that is going to be the entire engine, right? So I will apply a little more heat, not too close to the connector or anything, so you're not going to melt the plastic because you're providing a lot more temperature very quickly. But yeah, that's how I do it. That's how I do it. That's how I check, and that's how you need to check it because otherwise the computer is going to get burned. All right, guys, I hope that you like the content that I'm trying to share in here. Please let me know if this is something um, that you like, you want more information like this to be presented to you. I don't mind. I have the time and I can explain more. I like to share knowledge. I like to transfer the knowledge to the new generations that are coming as a technicians. I try to help my fellow technicians around the world, including Pedro. He's a good friend and others that are always, learning like myself. I cannot say that I know everything, but I try to study a lot before I jump into anything. Same as Pedro, he takes the time to really learn whatever he does not understand. He hasn't worked on it. He always reach out, and that's what we do. I mean, we are a community that we like to help each other, trying to help others to reach the next level. Because yes, if you are like learning, this time you make all the questions you want. I would recommend you to write the questions on a notepad, and then when I give you the answer, write it down in there. So whenever you have that same question, you don't have to call me again. You already got the answer in there. And then repetition makes you better, makes you faster, make you learn more. And that's just how we technicians are, or we are. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. You like this content, you want to keep seeing it, subscribe. Share my videos with your friends. Tell them to subscribe as well. The more subscribers I get, the more I can stay here and share the knowledge. All right, guys. See you next time. Bye bye.